Okay, so let's go ahead and go over to here. Okay, now yesterday we talked about double replacement reactions, and that is where you had a salt plus a salt. Now, the question is, um, the question is whether you got a, oops, wait a minute here. Okay, with a single replacement, we're looking at a metal plus a salt. Now, for this one, yields a um, metal. Oh, and what I mean by prime, where is the single? Okay, so in a single replacement, you start with a metal and a salt, and then if something happens, the metal is changed to another metal, and the salt becomes the metal. Okay, so that's the main difference between these two. What are you starting with versus what you end with? So again, single replacement is the metal plus the salt, and if anything happens, the metal changes and the salt changes. With double replacement, you start with two salts, and when you put them together, you're going to get a solid um, or not, looking at the solubility table. Remember the black or white table. Okay, so let me look at an example here. Now we're going to be using something called a reactivity series. Okay, now this is a reactivity series. At the top, my tablet is not hooked up. That come on. I'm on a different computer than I normally use in lecture. Okay. All right. So let's look at this one here. Okay, we have silver nitrate. That'd be the salt plus nickel. And this would be the metal. Okay, so is anything going to happen? Okay, so what we're going to do, we're going to look at a reactivity chart. Now, this is a big long one. What you need to do is find the nickel, find the metal, which is right here. And the other one was the silver nitrate. So you'll find silver on here, which is right here. Now, if the metal is above the salt, this is the metal, salt. If the metal is above the salt, the reaction goes. So let's look at this now. So the metal is above the salt. That means this reaction is going to go. So what happens? What does that mean? Okay, so we have nickel now becomes the salt. In other words, they exchange places. That's where the replacement part of the name of the reaction comes into play. The two metals swap, and the nickel becomes part of the nitrate. And the original salt becomes metal. So that's the essence of silver. I mean, the essence of single replacement reactions. You compare the metal and salt on one side of the equation versus the other side. So that's all there is to it with single replacement reaction. You find the metal. Is the metal above the salt metal? If it is, the reaction goes. If it's opposite, where the metal is below the salt metal, then the reaction doesn't go. So for example, if we, yeah,
Oh, I was going to ask if you could give an example of that,
yeah,
of where it's not above.
yeah, let's do that. Well, let's involve zinc and nickel right here on the zinc. Okay, so zinc is above the nickel. So if we changed this reaction, so if we swap places on these, let's say we started with nickel nitrate, put these in parentheses, plus silver. What would happen here? So we're looking at nickel versus silver. Okay, nickel and silver. But in this case, The silver is the metal. Okay, so we find the metal in relation to the nickel. So is the silver above the nickel in this case? No, it's the
No, it's
opposite.
below.
Exactly. So if the metal is below what's in part of the salt metal, then the reaction won't happen. So this would be a no reaction. Now, the essence of a single replacement reaction is something called oxidation. Okay, and part of oxidation is another process that goes on simultaneously. It's called reduction. Oxidation is the loss of electrons, and reduction is the gain of electrons. So let's go back up here. So what's going on in nickel here? Nickel's going, if we look, take this apart, it'd be Ni plus and NO3 minus. So this nickel is a metal, so its charge is 0. So what happens is it goes from a 0 charge to a +1 charge here. That means the nickel is being oxidized because it lost an electron. So when this happens, let's get rid of this. So when this happens, you lose 1 electron. So in this case, the nickel is being oxidized from nickel metal to nickel +1. So that means that oxidation of nickel is going on. That means the silver, so this is oxidation. Let's get rid of the 1. Just that's losing an electron. That means this is oxidation. Now, the issue with something losing an electron, something's got to receive the electron. So that means the silver must be gaining the electron. Okay, so this is Ag plus. So here, going from a +1 to 0. So that means this gains an electron. Okay. So the table over here is a table of oxidations. And these are all metals now. Going from most want to oxidize. Okay, so if the metal is above the other one, that means it wants to oxidize more than the one below it. So in the metal up here on the first example, we had the nickel is above the silver in the salt. That means that nickel wants to oxidize more than the silver does. That's why it happens. So the silver now wants to oxidize more than the silver wants to be reduced. What happens? Here, the silver is below the nickel. So right now, the nickel is already in an oxidized state. It's +1, because NO3 is -1. So it is already oxidized, and the silver below it can't be oxidized because the nickel is above it. It takes precedence in the reactivity table here. So that's the technical explanation of why this reaction happens. Excuse me. So the bottom line the bottom line in a single replacement reaction, you compare, it has to be compared against a reaction table, which this is. However, it's really an oxidation table. Higher up you go, the more it wants to be oxidized. So if the metal, okay, the metal by itself, not with the salt, is above the salt metal, reaction goes. So if this is yes, reaction happens. Okay. So here we have the metal above the silver. It happens. That's the bottom line in single replacement reactions. Bottom line. Now there's various oxidation tables. Sorry. This is a really long one and complex. The one I'm going to give you on the test is smaller in scope. So it'll be less metals on there. But the bottom line, it doesn't matter how big the thing is. If the one metal is above the salt, it goes. And if that happens, then you just write the products. So then this would become a nitrate, the nickel, and the silver would become silver metal. Okay? That's the essence of this.
Professor.
Yeah,
So if there's no reaction, then there's no oxidation or reduction happening.
exactly. Exactly. Because if the nickel is above the silver, the metal salt, it's already oxidized because it's a +1. The metal is a 0. So this is already oxidized. If it's above the silver, then well, like in this case, the silver is a 0 because it's a metal. And does it want to become an Ag +1? That means it wants to oxidize. Well, the nickel takes precedent over the silver because it's higher. And it's already oxidized. So there's nothing can be oxidized now. That's why there's no reaction. Is that better?
Yeah, that makes sense. Are we going to have a sheet of the what's above and what's below on the
Yep.
test?
Yeah. You have to have a
Thank
sheet,
you.
otherwise you'd have to memorize this. It's just another another thing I don't believe in. So yeah, you're gonna have this table. It's gonna be modified. It's gonna be less of them. So it'd be easier to find the metal and the salt on the reaction table. It's the one we did yesterday, and I don't, because I'm on a different computer, that's where the one we used yesterday. But it's the same idea. You have to have, for single replacement, when you have a metal and a salt, you need a reaction table of metals, which this is. but it's really an oxidation table. Things higher up oxidize more than the ones below it.
Okay, and for stating the problem on the test, would you like us just to rearrange it, or do you want us to state whether or not there's oxidation and write that down?
Well, if you go on and look at the practice test, you'll find a single replacement question and a double replacement question. And on the single replacement question, I gave you it would look something like this. This wouldn't be here. And I would ask you, does that go or not? And then why? So the why part is the metal is above the salt or below it. That's the why, whether it'll go or not. So there's two parts. If it's a yes, then you finish this in. So you swap the metal and the salt metal for the reaction.
That makes sense. Thank you.
I had a question.
Uh-huh.
So do we have to do the solubility for single replacements too, like we did yesterday with the double replacement?
I'm not yesterday we did double replacement in class in the lecture. Were you there for
Yeah.
that? Okay. All
Do
right.
we have to put the solubility like the AQ or the S for the single replacements?
Well, technically, yes. So this would be an AQ, and this would be a solid. But that's not as important on the single replacement. The main thing is the relationship between the two metals, which is above. So that's optional for our class. Normally, you would put AQ for the salt and S for the metal. Now,
Oh,
our
okay.
wet lab next week, you can actually we'll be doing this again only in real time. You're gonna oh man, you're gonna be dropping the solution of silver nitrate onto the metal nickel, and you'll see something may happen. What happens in this upper case, because the nickel is higher than the silver, what happens is the nickel dissolves and the silver comes out as the metal. So the two metals swap, so you end up with a nickel nitrate plus the silver metal. So this would be an F, this would be AQ. But the main thing is this, you swap the two metals and see which one is above. If the metal is above the AQ, it wants to be dissolved. I mean, excuse me, it wants to be oxidized. That's why it goes to an N nickel plus. This is the oxidation state here.
Professor, nothing technically changes though. I mean, it starts as an AQ and it's going to end as an AQ, correct? Or I
Okay,
mean,
yeah, you'll have the AQs are not the same though. But yeah, you always start, what you start with a metal and a salt, and you end with a metal and a salt. So this is the metal, then it'd be the salt. If it happens. If it doesn't happen, then nothing changes. So you end up with the same salt and the same metal. But if something does happen, then the metals swap places. Bottom line. The double replacement students find easier than the single replacement. Once you understand the concept of whether this reaction happens, it's very straightforward. But until you understand that concept of whether the metal is above the salt metal, it happens. If it's below it, it won't happen. If you look at on the right here, this is what we started with over here. Same thing. And what we're doing on the top one is we're oxidizing the silver, reducing the nickel. It's already done down here. So that's why it's not going to go in reverse. So this is a one-way trip. This does not go like that, only forward. So when you're studying single replacement reactions, two parts. Does the reaction go or not? Yes or no? If it's yes, then you swap the two metals for the product. I'm sorry, what? Misty, did you have a question?
No, I don't. Sorry. I just joined the meeting. I gotta turn my mic off.
Oh, okay. Yeah, at least you don't have dogs at the front door with someone ringing your doorbell. Okay, well, that's it on single replacement reactions. And I'm sorry was late to this. My wife needs to, health-wise, needs to get back on track here. Okay. Any other questions? Okay, let's finish this.